Hello, in today's experiment we will analyze period of oscillation with two different masses. Here we can see that we have an apple and a lime. Both strings have the same length. Do you think that they will have the same period of oscillation? Let's see.
Okay, we're gonna have a distance of 30 centimeters from the origin from where we're gonna drop them. We're gonna start counting when both objects return to their initial position. That is one period of oscillation.
One, two, three, four, five.
In this particular project, we will be looking at one of the applications of oscillatory motion. In this particular experiment, we will look at a simple pendulum. Such is essentially a point mass that is suspended from a string, and the periodic motion that is generated from it when it's released from an original angle or its amplitude. This will cause the strings to swing back and forth and will generate the equation for motion for the simple pendulum. The time required to complete a cycle, which is essentially from crest to crest, is called a period. In this case, we are trying to prove that no matter the mass, if the length of the string is the same, they will complete the same period for the oscillatory motion.
Now we're going to see what the experiment represents graphically. So we released the apple and the lime at a distance of 30 centimeters from its origin in a horizontal line. We can state that this will serve as our amplitude. So we can state that here is our amplitude, which is going to be equal to 0.3 meters. And that period of oscillation will start like this, saying that this crest will be its same amplitude on the negative side. And our period of oscillation will start from this crest to this crest, completing one cycle from here to here. Now we're going to see how this period can be calculated to predict the seconds it's going to take.
Theoretically speaking, our period formula is T equals 2 pi times the square root of the length of the string over the gravity. If we substitute these two values, we have 0.60 meters over 9.81. It gives us a period of 1.55 seconds multiplied by 5, which is the number of times there was a period. It gives us 7.77, which is roughly 8 seconds, which is what the chronometer marked. Now, of course, this is not the most perfect one because there were many possible sources of error. First of all, the rule might have not been exactly at 30 centimeters, or in the oscillatory movement, the two objects might have crashed into each other or moved from their path.
Now, pendulums might seem to be very simple, but they actually are very useful for education purposes. For example, if you teach someone about pendulums, you can also introduce them to waves, which is what my partner explained before. In real applications uses, we can use them for, let's say, a seismometer. When there's an earthquake in a place, a seismometer, which is basically a pendulum which moves with the movement of the ground, marks how grave the earthquake was. Or you could also use it for the internal mechanisms of a clock, which a pendulum was used for its precision in period in order to mark time. So thank you for your time and hope to see you soon.